Hi everyone. Today we're going to study integration by substitution. Specifically, integration by substitution method helps us find antiderivatives when the integrand is the result of a chain rule derivative. Here are the steps. Step 1. Look carefully at the integrand and select an expression g of x within the integrand to set equal to a variable u. Let's select g of x such that g prime of x is also part of the integrand. Step 2. Substitute u equals g of x and du equals g prime of x dx into the integral. Step 3. Evaluate the integral in terms of u. Step 4. Write the result in terms of x and the expression g of x. This is example 1. Use substitution to find the antiderivative of the integral 6x times the quantity 3x squared plus 4 raised to 4 dx. For our solution, step 1 is to select u. Let us select this 3x squared plus 4 as the u. And let us take the derivative of this expression. So we have du equals 6x dx. If we analyze the integrand, the 6x and dx here is the value of du. And we say that this du is in the integrand already. Step 2. Substitute u and du in the integral. So we have now this 3x squared plus 4 is the u, and this is raised to 4, and the 6x and the dx are equal to the du. And step 3 is to evaluate the integral in terms of u. We're going to use the power rule, so we have now the u raised to 5 over 5 plus c. Now the step 4, to write the result in terms of x and the expression g of x. It means we're going to return the value of u from here. So we have now this 3x squared plus 4, the quantity is raised to 5 all over 5 plus c. This is the final answer. Example 2. Use substitution to find the antiderivative of the integral of z times the square root of the quantity z squared minus 5 dz. For our solution, let us rewrite the integral showing that this radical is in the form of fractional exponent. So we have now the integral of z times the quantity z squared minus 5 is now raised to 1/2, then dz. And from here, let us do step 1 to select u. We're going to select the quantity z squared minus 5 as the u. And then let us take the derivative of both sides. So we have du equals 2z dz. Now considering the integrand, we have here the z dz, but the value of du equals 2z dz. This constant 2 on the right side we're going to eliminate by dividing this equation by 2. So we have now du over 2 equals z dz. Step 2. Let us now substitute the values that we found in step 1. So we have now the integral of this quantity z squared minus 5, that is the u, and then raised to the exponent 1/2, and this z, dz, is equal to du over 2. So we copy it here. Now, this denominator 2 is a constant that we can put it outside the integral sign. So we have now 1/2 times the integral of u raised to 1/2 du. And we can do step 3 to evaluate the integral. Let us use the power rule in here. So we have the constant 1/2 times u raised to 1/2 plus 1 all over 1/2 plus 1. The 1/2 plus 1 is equal to 3 over 2. So we will write now 1/2 times u raised to 3 over 2 all over 3 over 2. Let us simplify the denominator 3 over 2 by flipping it up, thus making this denominator 2 here to be the coefficient of u in the numerator. So we have 1/2 times 2 u raised to 3 over 2 over 3. We can cancel the 2 and the 2. So we simplify our answer into u raised to 3 over 2 over 3. Then we write plus c. And step 4, write the result in terms of x and the expression g of x. So the value of u from step 1 is the z squared minus 5, and then this is now raised to 3 over 2 all over 3 plus c. This is now the final answer. I hope you learned something from this video. See you again next time.